Please welcome to my video. Today I want to discuss the points of the hash table second part. That is part 2, and on the topics of the discussion on the hash table and also the secondary clustering, formation of secondary clustering and the solution of the secondary clustering, that is the chaining process of the how chaining process is introduced and to resolve the secondary clustering, and a brief discussion of the previous video. We know hash table is a linear data structure. So it always hash table is used to store the data at a specific bucket and to access data. And it is the primary cause to use the hash table. So as a data structure, we have already discussed the hash table details, that is primary data structure, secondary data structure also. And today we want to discuss a brief discussion of previous video, that is the how hash table is formed. Hash table formation by a key and also data with the mapping. Key and data with the mapping. Suppose key and data with the mapping, hash table is formed. This is the hash table and this is the index. This is the data. Okay. So each hash table contain the column where index number is there. We know the hash table also a zero-based index, permit zero-based indexing, and zero-based indexing start from the 0, 1, 2, 3, 4, 5, 6. Okay, I am extending the figure, and now 6, 7, 8, 9. More room is originated. 0, 1, 2, 3, 4. So this is the index number, and this is the room where data will be submitted. How the data will be submitted, data will be absorbed at the free slot bucket point. It is our criteria. Hash table is a linear data structure. Suppose data value 53, 63, 59, 69 other group of data. We want to put the data through hash table. Hash table, that is data and key. Key, what is the key? Key related with the volume of the hash table. Key related with the volume of the hash table. Where we have already selected the 0 to 9, that is 10 room of the hash table, that we can select the key as 10. It is not a such way that the number of key related with the number of room. No, it is not such rules of the hash table, but it is customary that the key is related with the volume of the free slot of the hash table. So here 10 slot is there, and I am choosing the key 10, and I am choosing the possibility, the procedure of the mapping procedure by division and remainder process. So 53 mod 10 equal to remainder 3. 63 mod 10 remainder 3. 59 mod 10 remainder 9. 69 mod 10 remainder 9. Each and every case there should be a reminder, and reminder indicates the point where the data will be located. This data will be submitted. So here reminder is 3. So 0, 1, 2, 3. 3, that is 53 will be at that position. Now coming the 63 at that position, of course it will be at the same position, but it is not possible because the one room only for the one data. So 63 is not possible, but 63 is waiting. 63 is waiting for to make entrance at this room. Not possible. Then another solution, then it is formed a primary clustering is formed. How to resolve this primary clustering? Primary clustering is resolved by using the linear proving. We already discussed at my previous video that primary clustering will be solved by the linear proving. Linear proving means 63 and 53. When the slot is not available, a specific slot, that is number 3 slot. Slot number 3, that is the principle of the 63. It is not available. Then it will take the position next slot. Next 4, it is bracket. So 63 will be shifted at the position of the at that position, that is slot number 4. What is the rules? Rules is that when 3, that is a specific slot, is not available, then we have to see the next slot. If it is vacant, then data will be submitted at that point. If it is not vacant, then I will try the next slot, and then I will try the next slot. In this way, I will check linear way. So it is linear probing. I will check the linear way for each and every slot sequentially. And if it is found vacant, then data will be submitted. It will be shifted at that point. So 63, 4 number plot is vacant, 63. And then the coming then 59. 59, that is reminder should be 9. Then data room is 9. So 59 is that position. Next time coming 69. 69. At this room, it is already filled, so this data will not possible to make entrance at that point. So 69, then the rules is saying that next slot, no slot is there, so next slot means 0, and then 0 slot, 0 at the point, and at the index number 0, the 69 will be shifted at that point, the 0 slot. Okay. 69, reminder is 9, so it should go at the point of 9, that index number 9, but it is not possible because 9 already fulfilled. Then it is coming at 0 slot. Next slot is 0, so it is coming 0 slot. In this way, the data will be shifted. It is called linear probing. It solved the primary clustering today. The next part with the content of the secondary clustering. What is the secondary clustering? Suppose this clustering, suppose the data which is already filled at that position is okay. And next, I am filling another set of data, 12. Data set is 12. So our data is 12, 13, 14, 15, 16, and 24, and 25, and 33. So the set of data is started from the 12. So 12 to, that is vacant. So 12 will be shifted at that point. Next data 13. 13 is not vacated. It is already filled, and this is the position. 53 is already here. So 13 is not possible to make enters. So 13 will be waiting for her room, for this room. Next data is 14. 14 already vacated, already filled by 63. So 14 we have to wait. The data will wait for the next for this room because it is already fulfilled. So 13 and 14 is waiting. Next data 15. 15, and this is the 15 number. Of course, it is okay. The room is vacated. So 15 will take the position at this room, 15. And next data is the 16. 16 is possible because it is already vacated. 16 already done. And then 24. 24, only two set of data is already waiting for their room, and now they are coming another position, another room, that is another data, that is 24. No room here, so you have to wait for the room. Then 25 here, you have to wait for the room, and 33, that is 33, this is the point, we have to wait for this room. So I have seen that this 3 row, 3, 4, 5, and these 3 index number, room is not vacated, so they are waiting some data. What is the solution to solve this problem? Because it is called the secondary clustering. And in this way, I am saying that as an example, it is 3 data, but it is so many data can be waited because it depends on the volume of the data. How many volumes data we are dealing, how many volume of data is waiting and recycling, and this has to be. In this on these topics, it depends on the how many data is waiting for this hash operation. So here 3 set. That is, we can say that the 3 data is waiting at the room number in front of room number 3. Then linear probing is not applicable here. Chaining process means 53 will be linked with 13 by pointer, 13 will be linked to 33 by a pointer, and similarly 63 with 14 and 14 with 24, 15 with 25 will be linked to access data by linked list. So linked list will be applicable at that point. Using linked list, we can establish a link, and by this link, we can access the data. That is, using 53, we can access 13, also 33. Using 63, we can access 14 and 24 by using the linked list. So linked list is the only solution, and this is called the chaining process. As a chain, we can chain, we can make this chain, and if the data is volume is big, then we can make a chain to access data. And in the linked list, we see we have already discussed as a linked list at another data structure that the first pointer as a head point of the linked list is very essential and very important part of the linked list, because each and every data have not direct access from the first point. First data know the second data address of second data, the second data knows the reference of the third data knows the reference of the fourth data knows the reference of the fifth data. In this way, data is connected. So no chance to access the sixth number position data by using the first data, because first data knows the address of second data knows the address of the third data for fourth data. In this way, fifth data is possible to access the address of sixth position, data of the sixth position. So in this way, data is connected. Then it is a linked list, so it consumes more memory because it uses pointer consume more memory, so it is very memory consuming programming. So in this way, it takes also time. But solution is chaining process. So I have already discussed the second part of the hash table. Second part, that is definition of the hash table, already discussed that first part. Again, I am discussing that is a linear data structure. It using the linear data structure, it accesses the data, it stores the data, and it utilizes the data. And in this way, hash table is searched, mainly searching purpose. It is used at database or any other types of the application. And the hash table facing the two problems mainly. First is the primary clustering and secondary clustering. Primary clustering is solved using the linear probing, secondary clustering using the chaining process. Chaining process just like merely a linked list, so it consumes more memory. Linear probing is like an array. Actually, this hash table is merely an array. It is situated at a contiguous memory location. But when we using the linked list as the chaining process, then we don't know where the data is located. So this data, location of the second data, is possible by accessing the first data. First data knows the access point of the second data knows the access point, difference point of the third data. In this way, data is linked. Thank you. This is the end of this second video of the hash table, and in the next video I will discuss the problem of the hash table and question answer of the hash table. Thank you.